In this video, we will be talking about linear equations in one variable. And let's start with the definition. The linear equation is an equation that can be written in the following form. ax plus b equals 0, where a and b are constants, or that's another name for numbers, and a is not 0. And one of the things that I want you to notice about linear equations is that the exponent on the variable x is 1. So here are some examples of linear equations. The equation 3x plus 5 equals 0 is linear. Notice it's in the same form as our definition, with a equal to 3 and b equal to 5. And again, notice that our exponent x, that our variable x has exponent 1. Now let's look at the next equation. It doesn't look like our form, but since we can add to both sides of an equation the same number and keep the equation equivalent, we're going to add the opposite of 6, which is negative 6, because that will give us 0 on the right-hand side. And notice that we now have our linear equation form with a equal to negative 2, the coefficient of x, and b equal to 1. Again, here's x, and our exponent is a 1. So here's some things that are not linear, some equations that are not linear. If you have an equation with a variable that has an exponent other than 1, for example, this one with the 3x squared, negative 3x squared, that is not a linear equation because the exponent on x is 2. If our variable appears in the denominator of a fraction, like in this example, 3 over x, this is not a linear equation. If our variable appears within an absolute value sign or under a square root sign or a radical sign, as in our example, 2 times the square root of x, this is not a linear equation. Now, to solve linear equations, that means that we want to find the value of x that makes the equation true. And linear equations will have exactly one solution, provided that a, the coefficient of x, is not equal to 0. So let's solve some equations, and we'll be checking the solution as well. So here's our first equation. Negative 7x minus 4 equals 31, and we want to isolate the variable. So we're going to add positive 4 to both sides because that will move this negative 4 over to the right-hand side of our equation and bring down the negative 7x. And as you know, a negative 4 added to a positive 4 is 0. That's what we wanted. We wanted to move this negative 4 over. And 31 plus 4 is 35. Now, to isolate x, we now need to get rid of its coefficient, negative 7. And again, we can divide both sides of this equation by negative 7 to get an equivalent equation, and that will help us isolate x. And then here in this fraction, the negative 7 can be reduced to leave a 1x, or just x, and 35 divided by a negative 7 is negative 5. Okay, we're going to check. And how you check is that you substitute your solution into the original equation. So I'm substituting in the negative 5 where the x was, and we're going to see if we get a 31. Okay, this multiplication is going to happen first. Negative 7 times negative 5 is a positive 35, minus 4, and we know 35 minus 4 is 31. So this equation checks. And we're ready for our next equation. Okay, in this equation, we have variables on both sides of the equal sign. We want to get them to the same side of the equal sign. So I'm going to add a negative 5y, which is the opposite, so that I can get the y's together on the left. This is just a personal choice. We could have moved the 1y to the right, but I moved the negative 5y over. And 1y minus 5y is negative 4y. Bring down the negative 5 equals Okay, over here we have 5y minus y, which is 0. Bring down the negative 3. Okay, now we need to isolate the y. So this now looks a lot like our problem from above. And so we're going to add positive 5 to both sides so that we can isolate and get that y on the left by itself. Negative 4y comes down. Negative 5 plus a positive 5 is 0, so those cancel. And negative 3 plus a positive 5 is 2. So now we have coefficient of negative 4 times y. We're going to divide both sides of the equation by that negative 4. And as you know, that's going to give us a 1y on the left because these negative 4s are going to cancel. And on the right-hand side, we have a common factor of 2 in this fraction. So we can divide the top and the bottom by 2 to simplify this fraction. And so we end up with 1 over negative 2. And you know, we don't want to leave a negative in the denominator of a fraction. So a positive 1 divided by a negative 2 is a negative. So we just put the negative in front of the whole fraction. It means the same thing. Okay, we're going to check this. Now, if you're not fond of checking these fractions by hand, then I recommend you use your calculator, or some of you may want to use the decimal, negative 0.5, and then your calculator. But I'm going to go ahead and use substitute in the negative 1/2 so we can practice our fractions a little bit more. And we're going to check to see if the left-hand side equals the right-hand side. Now here, since I am going to add these two negative fractions, I need a common denominator. And common denominator between 2 and 1 is 2. So my negative 1/2 stays the same. My negative 5 over 1 becomes negative 10 over 2. And then I add the numerators, keep the denominators, so I get a negative 11 over 2. On the right, we're going to multiply first, multiplication before subtraction. And negative 5 over 1 times negative 1/2 is negative 5 over 2. I'm going to line these up again so we can get that common denominator, which is still 2, just like on the left-hand side. I'm going to change the 3 to a 6 and add negative 5 plus negative 6, which is a negative 11. Keep the denominators, so we are getting indeed the same thing on both sides of the equal sign. In this next problem, we have parentheses, and we're going to use our distributive property to simplify first. So we distribute that negative 2. And negative 2 times 2z is negative 4z. And negative 2 times 7 is negative 14. And that equals 1. We bring that down from the right-hand side. We're going to isolate z, so we have to move the negative 14 to the right, which means that it's opposite, positive 14. And that's going to give us on the left negative 4z. The 14's cancel, equals 15. And again, we're going to get rid of our coefficient of negative 4, so we're going to divide by negative 4 both sides. And so that on the left, the two negative 4's cancel to a 1z. And on the right, we have this negative 15/4. Remember, I told you to put the negative sign in front of the fraction rather than leaving it be in the denominator. Okay, we're going to check. Again, this may not be the most fun thing to do with these fractions, but we got to do it. So I'm substituting in, and we're going to see if we get a 1 on the left, just like we have on the right. Now, order of operations, we're going to look inside this parentheses and do this multiplication first. And that's, I'm going to put a 2 over 1 so that we can do some reducing here. The 2 and the 4, and then multiply across. So we have negative 15 over 2 plus 7. And we want to see if that's going to equal 1. Now I'm going to use my distributor property, primarily because there'll be less fractions that way. And so I'm going to distribute the -2, and that means that's -2/1 times -15/2 plus -2/1 times 7/1. And in the left, this first set of fractions, the 2's do reduce, they cancel, which leaves me with a -1 times -15, which is a +15. And in the second fraction, I have a -14, -2 times 7. 15 minus 14 is 1, so that checks. Okay, this one's looking pretty complicated, but we have two parentheses. See the subtraction sign in front of the second parentheses? You're going to distribute a -1 to handle that. So in the left parentheses, we get a -2x plus 14. The next parentheses, we get a -x minus 5, and that equals 5. And now we're going to add the like terms on the left before we start moving things around. So -2x and a -x are like terms, and a 14 and a -5 are like terms. -2x minus x is a -3x, and 14 minus 5 is 9, +9, and that equals 5. Now we're going to isolate x on the left. So we want to subtract 9 from both sides. So we get, well, here we get -3x. The 9's cancel, equals to 5 minus 9 is -4. Now this -3 in front of the x, we're going to divide both sides by -3 so that we have a 1x on the left. And these two negative signs on the right cancel to give a +4/3, which is our solution, and which we're going to check. And again, not the most fun thing to check with fractions, but let's substitute in the 4/3 where the x is. And we're getting a lot of practice with fractions here. So this time I'm going to do this a little bit differently. I'm going to go ahead and simplify the parentheses first before distributing, just for a different version. So I need a common denominator, and between 3 and 1, that would be the 3. So we're going to change that -7 to a -21/3. Now we're going to add the -21 with the +4, which gives us a -17/3. Keep the denominator. And that -2, we're going to change that to -2/1 and then multiply it times our answer. And multiply across, we get +34 on the top and a 3 on the bottom. Okay, now we're going to go to the right-hand side and find a common denominator in that parentheses, which is, again, the common denominator is 3. Just have to change this 5/1 to 15/3. These are both positive, so we're going to add the numerators. That's a 19/3. And we've got that negative between those two answers. That's subtraction sign. So 34 minus 19 is 15. +15, and 15/3 is indeed 5. So this problem checks. Okay, there are times when we have equations that appear to be linear but are not. So this equation that we started out with the two x's, if we subtract x so that we can get the x's on the same side of the equation, you're going to notice that the x's drop out, and we end up with 0 equals 5. Now, 0 does not equal 5, so we would say that this equation has no solution. So here are some solutions for the equation ax plus b equals 0. You have three cases. One is the case with no solution. So if when you're solving your equation, you end up with a statement like 4 equals 0 or 3 equals 2, something that is always false and doesn't have a variable, then you have the no solution case. If you are able to solve for x and get a one value and then check and it works, then you get your solution. And if, however, your variable drops out and you end up with a statement that's always true, like 0 equals 0 or negative 3 equals negative 3, then you have infinitely many solutions because every value of x works. Okay, so let's try this with this next example. We're going to determine whether the equation has no solutions, one solution, or infinitely many solutions. And we're going to distribute on the left. That's a 2x minus 8 equals 2x minus 8. If we were solving this to get the x's together, we would subtract 2x from both sides. So let's just do that so that you can see what happens. The x's cancel on the left and we end up with a negative 8. The x's cancel on the right and we end up with a negative 8. This statement is always true because negative 8 does equal itself. So that tells you that this particular equation has infinitely many solutions. Any value of x in the original equation will give us a true statement. So there's an infinite number of numbers that actually will make this equation true.